Welcome to the deep dive. Today, we're pulling back the curtain on something we all interact with constantly, e-commerce. Our mission is really to extract the most important nuggets of knowledge, from the architecture of a real-world online platform. This isn't just about the storefront, you see. It's really about understanding the clever engineering that lets these systems handle, well, massive global traffic, stay incredibly secure, and deliver lightning fast experiences, even when everyone's hitting refresh during a flash sale.
And that's precisely it. That's what we'll explore. My background is in designing and building these kinds of scalable systems for some pretty big names in retail. So yeah, I'm excited to share what truly goes on, behind the scenes of a modern e-commerce platform. We'll try and demystify the architectural decisions that make your online shopping feel so effortless.
It's fascinating because, you click buy and it just feels instant, almost magical sometimes. But beneath that seamless experience is just an extraordinary amount of complexity.
And ingenuity, too. So, okay, let's unpack this. We're going to dive into how it all actually works. So every great solution, they say, it starts with a significant problem, right? What was the core business challenge here? What initially demanded such an advanced architectural approach?
Well, the client came to us with a really clear, pressing need. Their existing legacy system was, frankly, buckling under the pressure. They needed a platform that could handle these immense traffic spikes from global flash sales, support users across every continent, really, and provide highly personalized shopping experiences. And crucially, all of this had to happen without sacrificing speed or, of course, ironclad security. Their old system just couldn't scale. It couldn't meet these modern demands. It was becoming a significant bottleneck. Right. And we've all felt that frustration, haven't we? Trying to snag that limited time deal only for the website to just slow to a crawl. Or worse, it crashes entirely. So this entire architecture was essentially built to banish those frustrating pain points for the user. That makes perfect sense. Okay, so given those high-stakes challenges, how did you even begin to map out a solution? What was the overarching strategic blueprint you drew up to tackle this?
We opted for what we call a hybrid architectural approach. It's a bit of a mix. This basically allowed us to leverage the robust managed services of Azure for a lot of the core functionalities,
Yeah.
but also integrate flexible open source tools where maybe they offered specific advantages or just more control. What's fascinating here is how these diverse elements actually complement each other. We built it around a static front end for speed, a serverless backend for that incredible scalability we needed, an API gateway sort of acting as the traffic controller, and then a distributed NoSQL database for flexible data handling.
That sounds like a really powerful and pragmatic combination, getting the best of both worlds effectively. So if I'm a user, right, and I'm tracing my journey from the moment I land on the site, how does my interaction with, say, browsing products or adding an item to my cart, how does that translate into this technical flow you've described?
Okay, so it all begins with you interacting with a React front end. Think of React as the powerful engine behind the user interface you see and click on. Now, this front end, it's hosted on Azure Static Web Apps, which is fantastic because it delivers static content like your product images, page layouts, incredibly fast and securely all over the world. Then when you perform an action, maybe searching, filtering, adding something to your cart, those requests first pass through an API management layer.
Okay, hang on. What exactly is an API management layer for maybe our listeners who aren't familiar?
Good question. Yeah, think of the API management layer as like the intelligent front desk for all incoming requests. It acts as a central control tower. It routes requests securely to the right backend service and often handles things like checking authentication or rate limiting before a request even hits the main application logic. So from there, your requests reach Azure Functions. These are our serverless backend components. Serverless here just means the cloud provider, Azure in this case, automatically manages all the underlying infrastructure. It scales up and down instantly with demand. This is incredibly cost-effective, especially for unpredictable traffic spikes like flash sales, because you're only paying for the compute time you actually use, not for servers sitting idle. These functions, they handle all the critical business logic, updating your cart, processing an order placement, that kind of thing.
Right, so the initial interaction is handled super swiftly by those serverless functions, which, yeah, sounds brilliant for handling that bursty traffic. But what happens once an action, like an order, is actually initiated? Let's talk about the engine room, all those intricate behind-the-scenes processes.
Okay, yeah. So once an order is placed, for instance, it's not processed immediately in a blocking way where everything else waits. That would be inefficient. Instead, that order data is pushed to a message queue. Think of this like a digital post office, maybe. When an order is placed, it immediately drops a letter, the order data, into a mailbox. This allows the system to instantly confirm the order back to you, the user, while the post office then reliably delivers that letter to other services like inventory or payment at their own pace. And this is where the asynchronous magic happens and the power of microservices really comes into play. That message sitting in the queue then asynchronously triggers various microservices. Each one is dedicated to a specific task. So you'll have one microservice for inventory updates, another for payment processing, and maybe yet another for sending out notifications to the customer.
That sounds brilliant for resilience, definitely. But I imagine message queues and microservices, they can also introduce complexity, maybe in debugging, is that right?
Sure.
How do you manage that added layer of moving parts?
Yeah, you've absolutely hit on a key point there.
Hmm.
While this asynchronous microservices approach ensures incredible efficiency and resilience, because, like you hinted, if one service temporarily fails, it doesn't bring down the entire system. It does require a really strong emphasis on observability, seeing what's going on, and clear communication between the teams working on those different microservices. If we connect this to the bigger picture, though, it's a fundamental shift. It allows individual teams to develop and deploy their services independently, which drastically accelerates feature rollout and innovation. It's like moving from one single slow assembly line to multiple specialized workshops, each optimizing their part without halting the whole factory.
Makes sense. Okay, switching gears a bit. In a world where data breaches are unfortunately way too common, security has to be paramount, especially for e-commerce, handling sensitive user info, credit cards. What comprehensive security measures were implemented? How did you fortify this system?
Absolutely. Security was, well, it was a non-negotiable top priority from day one. We implemented multiple overlapping layers of defense, didn't rely on just one thing. For robust user authentication, basically, how users log in and prove who they are, we used OAuth2 with Azure AD B2C. This is a really robust industry-standard way to handle user logins and identities. It lets users sign up and log in securely, even using things like social media accounts if they want. Beyond just login, all data, whether it was moving between services or just sitting stored in databases, was encrypted, both in transit and at rest. Think of it like locking it in a digital safe constantly. And then, to protect against malicious traffic, things like bot attacks or common web exploits, we deployed a web application firewall, or WAF. That sits right out front, in front of the content delivery network.
Can you explain WAF a little more? What exactly does that do?
Yeah, sure. A Jawar acts like a digital bouncer, almost. It sits in front of your website and inspects all the incoming traffic. It looks for suspicious patterns or known attack signatures before that traffic ever reaches your actual servers. It filters out the bad stuff early. We also implemented rate limiting to prevent abuse, things like someone trying to guess passwords over and over, or just flooding the site with requests. And finally, for the internal services, the components that only need to talk to each other inside the system, we use private endpoints. That enhances isolation and prevents any unauthorized external access attempts.
Okay, that sounds really comprehensive. But even with the best plans, real-world development, it always throws curveballs, right? You're dealing with global users, massive traffic. What were some of the toughest challenges you actually encountered during development or operation? How did you tackle them? Any particular war stories that come to mind?
Oh, absolutely. It's never a perfectly smooth road, is it?
Right.
We definitely faced a couple of significant hurdles. Latency in certain geographical regions was a massive one. Imagine trying to deliver a lightning-fast checkout experience to someone in, say, Sydney when your main servers are maybe in the US or Europe. That physical distance is a constant battle against the speed of light, essentially. We tackled that mainly with edge caching, which essentially involves bringing frequently accessed data much closer to the users. Almost like having mini warehouses of information strategically placed around the globe.
Right, shortening the distance the data has to travel.
Exactly. Another tough challenge was handling complex authentication flows, especially when we had to integrate with various, sometimes older external systems. It could become a tangled web very, very quickly if you're not careful. For that, we worked hard on simplifying the token flows. We particularly found using an open source solution called Keycloak helpful, especially for our development environments. It just helps streamline that whole process significantly, making testing and integration much smoother for the dev teams.
It really sounds like a constant game of optimizing and refining. So once this entire system is up and running, how do you keep it performing at its peak? And also ensure you're managing costs effectively? What strategies and tools were in place for that continuous monitoring and ongoing optimization?
Yeah, it's definitely not set it and forget it. For comprehensive observability, basically, seeing exactly what's happening across the entire complex system, we relied heavily on tools like Azure Monitor and Prometheus. Azure Monitor gives us deep insights into all our Azure services, how they're behaving, while Prometheus, which is a popular open source monitoring system, is great for collecting real-time metrics about how every single part of the system is performing: CPU, memory, request times, you name it. This allowed us to set up really detailed alerts for any anomalies, create custom dashboards to visualize key health metrics at a glance, and crucially, implement autoscaling capabilities. So the system automatically adjusts resources based on load. The whole point of these tools is to be proactive, to stay ahead of potential issues, respond rapidly if something does go wrong, and continually optimize costs by ensuring resources are scaled up and down based on actual demand, not just sitting idle wasting money. It's about being proactive, not just reactive when things break.
That sounds like a truly intelligent balance you achieved there between maintaining that high performance and keeping an eye on the budget. It's not just about having the tools, like you said, but knowing how to interpret the data and act on it effectively.
Wow, this has been an incredible deep dive, really. From understanding that core business challenge that started it all, to the smart hybrid architecture, the intricate user flow, asynchronous processing, and those robust security measures, we've truly pulled back the curtain on how these complex systems support our everyday online experiences. So what does this all mean for you, the listener, maybe beyond just thinking about e-commerce?
I think it means understanding the underlying principles of these kinds of distributed systems is incredibly valuable today. It's not just about the specific technologies we mentioned, Azure, React, whatever they change all the time. It's more about how they combine. The philosophy, really, behind connecting flexible, independent components to create something resilient and effective at massive scale. Exactly. And you should consider how the principles we talked about, being distributed, hybrid, secure, as discussed today for e-commerce, they're really the fundamental building blocks for nearly any global digital service you interact with daily. Think social media, streaming, banking apps. This approach isn't just about selling products or handling flash sales. It's about building incredibly resilient and responsive systems that power our interconnected world. And crucially, it enables that rapid feature deployment and continuous improvement that's just impossible with the old, rigid legacy ways of building software. It's a completely different game.